So first of all, I will tell for Steven, who wasn't attending yesterday, that Yanis has recorded the presentation, yesterday's presentation, and we will make it public together with a couple of examples of scripts, a couple of testing data, and the presentation itself. Can you hear me well?
That'll be great. Thanks, Dimitri.
And yesterday it was mostly about data organization, data access, etc., and a little bit about how to run the pipeline. I showed the minimal script. And today I would like to talk about this topic, how to troubleshoot all sort of problematic cases when you run this kind of script, when you run the pipeline. First of all, how to identify the problems, what kind of problems you can meet, and the ways to fix them. Okay, so today, I think yesterday we reached this slide, so we can start with this today. As you remember, this is the minimal possible script to run the RoboPol pipeline. We import the pipeline itself, we initialize the object, and we run this method that contains, that calls a set of other methods following the flowchart that I was demonstrating yesterday, the reduction flowchart, and that is present in this paper of Oliver King, this flowchart. And yesterday, I think we discussed a couple of parameters, a couple of arguments passed to this, to the call of this constructor of the class. And today, I will explain a few more parameters, what they affect and how they change the output. And we start with this one that is called photometry method. It can be set to 3 possible values, 2, 3, or 4. First one is not in use anymore. I don't even remember what was it doing. So nowadays we use only these 3 photometry methods. If you set this parameter to 2, it will set the apertures, aperture size, the ones used for photometry, the red circles here, as a function of FWHM. So in the config file, there are these parameters, and as you can see in the comment, it's a diameter in units of FWHM of a best fit PSF profile. So what happens, the pipeline runs extractor. Extractor measures FWHM of these 4 spots and sets the aperture size as a multiple of FWHM multiplied by this factor given here in the config file. So if you simply, instead of 3 here, you set 6, the aperture size will double where you actually measure the counts. Somebody else has joined. Hi, Gina.
Hey.
Okay. Okay, for those who were absent yesterday, I will remind that. Yes.
Sorry, I have a time lag. So there was a method number 5, right? Is that out of use now?
To be fair, I don't remember what was that method.
Okay, maybe I'm wrong. Okay.
There was number 1, but I also don't remember what is that because we never use it anymore. Now I start remembering. Yeah, we were trying to do something else, but we either didn't finish it or something happened. I don't. In any case, let's focus on these 3 now. I will remind you what are these different colors, these circles and ellipses of different colors. The internal one, the yellow one, is the chrome aperture. This is as defined by Extractor. Sorry for the bells on the background. Potentially you can use it. There is this parameter in the config says use ellipse. If you set it to true, it will actually, the pipeline actually starts measuring the counts inside of the yellow ellipses. But I don't recommend to use it unless you know what you're doing. It's mostly for useful for galaxies measurement. Now Nikos is performing a project where he's trying to measure integrated starlight polarization in galaxies. But I would not recommend it to use in any other cases so far, at least, because it's not well tested. So usually we measure aperture within this red circle, and those are really circles. The space between red and blue is not in use. It's just a gap to have a gap, because there is still some starlight in between. And then the space between the blue and the green circle can be used for measurements of a background counts, unless it is specified that we measure background within the entire blue square. So this is regulated by this parameter background in square. So if it's set to true, we use the entire area of a square. If it's set to false, we will use this space between the blue and between the green circles. Okay. So yeah, this, if you set photometry method 2, the photometry will be performed using these 3 parameters. Each of them sets the size of the red, of the blue, and the green circles respectively. So if your background method, if your background in square is set to true, then you don't care about the the last 2 parameters, because we set these 2 external circles that will not be used. So you only care about this parameter, inner diameter multiple. So this sets the internal red aperture where we actually measure the counts. So why is it made as a function of FWHM? Because as far as I remember, for different functions, let's say you have a Gaussian distribution of your image of a star has a perfect Gaussian distribution, then it is possible to demonstrate that there is a particular optimal aperture size that gives you the highest SNR. And I think it's expressed something like 155 times FWHM. So there is a connection of the optimal aperture radius and the FWHM. And it's just a simple multiplication factor. So as far as I remember, for all other typical PSFs like Moffat function or some other functions, you can also demonstrate something similar, that there is some optimal aperture size. So we assume that this works for us as well, although our PSF pretty far from these kind of functions like Gauss or Moffat. We have, however, assumed that it's a good idea to use the aperture size as a function of, as a multiple of FWHM. Also, there are 2 ways to find this FWHM. You can use only the target, only these 4 spots, or you can use 10 best sources in the field and find the average of FWHM for those 10 best sources in the field. And this is regulated by these parameters. This parameter use target FWHM that you pass to the constructor. So if it's set to true, then the pipeline uses only these 4 spots of the target in the mask. If it's set to false, it will find several 10 good stars in the field, and we'll find the FWHM for those and average those values. Okay.
Dima, can I butt in a bit? So when choosing apertures for a source that you expect is low polarization. You know, if you want 0.1% or something, we found that these small apertures, like 3 FWHM, even smaller, can artificially increase the polarization, and it's not physical. So for high polarization sources, I agree that this multiple of FWHM and SNR is good, but for low polarization sources, I think, if I remember correctly, larger apertures were needed. Is that right?
I think it was mostly related to actually the brightness of a source, not to actual signal, to noise and polarization.
Oh, okay.
I guess you're talking, you're remembering why you created this photometer method for, right?
Yes. Mhm.
I will return to it in a couple of slides.
Okay, sorry.
Yeah, no problem. Yeah, and if you remember something, if I'm saying something wrong, yeah, correct me, please, because I may confuse things. But yeah, in this case, as far as I remember, it was not the issue with polarization fraction of a source, but the how bright the source is, how much of a mask it feels. But I'm not completely sure.
Yeah, so in the I'm remembering now. Sorry, in the Polaris flare paper where we show the aperture method, it's bright stars that we used to calibrate, but it was at small apertures those bright stars were more polarized than what the literature values were showing. So that's why I think.
Mm-hmm. Yeah. I think I know. Yeah, we will return to this in a couple of slides. So what I actually do when I, for example, process the data for the data release paper, I was not simply running this processing for one aperture size with fixed multiple of the FWHM, but I was running this script that is called run ppl3 in the example folder that I will share to you. It's basically the minimal script, but on top of this call of a pipeline, actually on top of both things here, we run a loop where we change this parameter, the multiple of FWHM. So it's done very, very simple. Okay, we can actually even remove that one to make it even simpler. Okay. So just for a set of floating point numbers, we run the pipeline, and every time in this place we change this multiple of aperture size, right? And then we can run a separate external script that will produce us dependence how the EVPA changes with aperture size, with aperture factor of FWHM, and how the polarization fraction changes. And as you see, in this particular case, it was changing for very small apertures, and then at some point it stabilizes and gets stable. But it was for EVPA. For polarization fraction, for fractional polarization, it was even better. It's more or less stable. Comparing to uncertainties of the measurements, it was negligible variability, right? So when I actually process the data nowadays, I just plot these kind of things. So first of all, I verify that there is this plateau, and I take the point of one of the points of this plateau with a minimal error bars, and I verify that it's also present in both EVPA and polarization fraction. And then I just go and check that everything is fine with image. I see that this aperture size is actually reasonable, that it's not crazy large, not crazy small. And I have a look that the red circles are well aligned with sweet spots. And I also check this image of a background count, these histograms of a background counts, and I see that the red line reasonably well corresponds to what I would say the mode of a distribution is here for each of the four squares, right? So this is essentially what I was doing for the data release paper and what I'm doing for standards paper now. I'm just verifying that these plots, these dependencies of polarization parameters, they converge to some value that they stop being a function of aperture size at some point, and I verify that everything is fine with these two plots. That's it. And using the data release paper, I made this distribution. So here there are several thousands of measurements, I think like 5,000 of measurements of blazars. And this is the distribution of this optimal aperture factor that I've selected this way in pixels. But you can translate it to these values of WHM, and roughly I can say that the optimal value of this aperture factor is somewhere between 2.5 and 3.5, let's say. So typically this curve stabilizes somewhere around 3, let's say. Okay, I hope it's clear. So I have an example of this script that produces this kind of plots. It runs the pipeline for several aperture sizes. Okay. Photometry method 3 is made especially for blazars that have a significant host galaxy contribution. So in the main RoboPol program, we had a bunch of blazars where the galaxy is quite prominent, so you can easily see it in DSS images like that. So compared to the field stars around. And if you tune levels if you open one of our images and tune levels in DS9, you see that essentially the galaxy fills the entire masked area. It is actually problematic because you cannot estimate the sky background properly because your galaxy contributes to each of the squares. So all these kind of histograms will be biased. Somebody is sending messages. What, Gina? I don't really understand what you're saying.
Sorry, this was just to not interrupt. If you want to see the dependence of the aperture of the polarization parameters on the aperture, there's a better plot in figure 10 of that paper. That's all I said, because the uncertainties are smaller and you can see them. It was just for, yeah, go ahead.
But this one is in the field, no? So we're not completely sure that in the mask it will be the same, no? Anyways, yeah. We can follow this suggestion and have a look here. Thanks. Yes, so what was I talking? That in some sources, we had this kind of troubles with the mask. So mask is an important thing in RoboPol, that it reduces the sky counts in this for the central target. But on the other hand, it produces a lot of problems for us. We spend much more time on the pointing, and sometimes the target is too close to the edge, and so we lose basically the measurement. And we have this kind of problem that in case of bright host galaxies, we are not completely sure in our measurements. So this particular case is Markarian 501. And in the data release paper, we actually write a note on this particular source that we do provide measurements. We are sure, more or less sure, that the VPA are reasonably well measured, but we are not completely sure about the polarization because we could not very well account for the sky polarization. And in fact, we compared our measurements with some other observers using different polarimeter, and we have quite a lot of deviation in polarization degree, our measurements from their measurements. In any case,
can I ask a question here, Dimitri?
Yes, please.
So in this sort of situation, then, would it be practical to obtain a separate observation of some sky nearby the target? You know, so there's an empty piece of sky to the upper left of the target there, right? So
Yes.
you could
Yeah,
do that instead. And
it is indeed the possibility. There is such possibility. And for example, we are trying now to measure supernova remnants. So there you are actually interested in an extended structure. And there is exactly the same problem that you have some extended structure covering entire mask. And there we are doing this kind of thing where we are trying to point nearby in an area on the sky without some stars and without this supernova remnant. And trying to estimate the sky polarization and sky contribution there. And then we subtract this from the SNR image.
Okay,
but
thanks.
Yeah, so this is totally right, what you're suggesting. I guess this is the only way to fix this. But in this particular case, because we were running this monitoring program and we basically had no time, and the pipeline that time, the control system was not prepared for this. So probably in that particular case would be easier just to drop this kind of sources, and that's it. In any case, the typical way, here there is another problem arising. If you start measuring this kind of sources, this kind of blazars with the same photometry method too, where the aperture size depends on the FWHM, then you will discover that your fractional polarization of the source depends on the seeing. So if the situation when you have bad seeing, you will have more dilution from the galaxy starlight that is on average unpolarized. More galaxy light will fall into your aperture, and compared to the good seeing when you have small apertures, when you are more focused on the AGN. So you have smaller aperture, you have more ratio of the light of AGN that is highly polarized to the galaxy starlight that is unpolarized will be higher for good seeing. So in order to avoid this kind of dependence that is totally artificial and related to this method of measurement, people usually use fixed apertures in this kind of cases. So we made this photometry method 3 that you can use in the following way. You just put photometry method 3 here, and then in the config file, you must be worried about this parameter. This is the size of the aperture in pixels, and our scale in RoboPol is fixed. It's this one, 0.435 arc second per pixel. So you can easily calculate. If you want 3 arc seconds aperture, you need to put 6.9 in this case. If you want 4 arc seconds, you just multiply, translate the scale to arc seconds per pixels to pixels and put them here, right? So photometry method 3 is used when you want just to fix these red circles to particular size, angular size or pixel size, okay? So yeah, here I show that in config, you just set this parameter to desired value and you measure with a fixed aperture, okay? Yeah, so this kind of, to avoid this kind of problem when we have extended sources totally filling out the mask, we have recently changed the mask. Recently, I mean last year, I think. So instead of that complicated mask that we used to have, that you can see the pattern in this paper, for example, I think. This one. So this is how the old mask looked. This is it was plus, empty plus, let's say, in the middle of the mask. And it produces this kind of shadow, right? Which is in our logo. And instead, with help of Anna, she calculated what size we need. And with a CNC, we made this kind of mask. This is just a square, and in fact, we removed these two holders, so we only have, instead of 4 holding legs, we have only 2. So we also say if we remove two extra shadows, we have more space in the field available now. So this one is very simple. It's just a hole in the square, and it gives you this kind of shadow, right? And the area here is larger than the square we used to have. So potentially it is better for this project when you want to measure galaxies, or it's also better in the case of bright standard stars. So the problem is that pretty much all unpolarized standard stars existing were very bright. They are of 8th, 9th magnitude, the best case, and usually even brighter. And we cannot make very short exposures. So even faintest unpolarized stars essentially fill the entire mask. And that's why when you run the photometry method 2 for them, we hit this problem that we actually measure not the entire star, but only the central part of it. And for this reason, I think there was this problem that for small values of this multiplicator of FWHM that is used as a size of aperture, we had these deviations from the standard values. Okay, and for this reason, Gina made this method, photometry method 4. Gina, do you want to explain how it works?
No, you're saying these things so correctly. Go ahead.
Well, I'm not completely sure how it works, but the basic idea is that instead of just simply setting the aperture size as a function of WHM or just a fixed value, now we make this growth curve for each of these 4 spots separately. And you can see it. It's just the counts that we have as a function of the aperture size in pixels. And then there is a special method that calculates the derivative basically of each of these growth curves. And it finds the point where the derivative reaches particular threshold values. These values are set here. This particular value, right? Yeah, you see parameter that finds saturation point in growth curve. And you should, Gina recommends to set this value for the field when you are interested in the processing the field stars, and this value if you are interested in the source that is in the mask. Gina, can you remind us how you process, how you define these values? You just process standards, I guess, and
exactly.
found which value give the best agreement with standard value polarization from catalogs, right?
Correct, yes. And just to add to what you said, so in practice, we don't really look at the derivative. We fit a polynomial to each of those curves. And there's the derivative of the polynomial, so it's a smooth curve that is that we use to calculate the derivative. But yeah, other than that, that's the same thing.
Okay, thanks. So which method to use? I don't know. I think Rafael, for example, uses always this photometer method 4 and what he's doing nowadays. I personally use photometer method 2 and this kind of plots. So instead of this growth curve and the counts for each of the spots. I forgot to say that in this photometry method 4, the pipeline it creates the growth curve for each of the 4 spots separately, but then it considers the pairs of spots. So the thing is that later I will again refer to it. Here you can see that unfortunately we have quite some difference between the in FWHM, in PSF of the 2 vertical spots and the 2 horizontal. Here you can visually even see that the vertical spots have more compact images than the horizontal ones. So what is going on here is that this method finds the values corresponding to this criterion for the 2 horizontal spots and averages it, and then does the same for 2 vertical spots. Okay. So I forgot what I was talking about before, but anyways, I think this is it. This is all I wanted to say here. So you choose on your, depending on your project, what you're doing. If you have very bright stars that are filling significant part of a mask square, we would probably recommend method 4. If you have faint sources like our blazars, I would probably personally recommend method 2, because statistically, I feel that it gives you lower uncertainties, because usually this method 4, it finds optimal aperture size that is too large in my opinion, and it gives you too much sky in the aperture, so signal to noise decreases. Yeah, in here I'm talking about faint sources. For bright sources, it's not the case. And if you have extended host galaxy and you are interested only in the core of a galaxy, then use method 3. Okay. Any more questions here or issues? If no, then we can start discussing. It's already 40 minutes past. So I've remembered 10 problems, 10 typical problems that arise when you start processing the data. And I suggest to go one by one and see how I would solve them if I was processing the data and met such problem. So problem number 1 is you process the data and you see, sorry. So you processed the data. Yesterday we were discussing that this is the content of a folder that is the output of the run of a pipeline, right? And that usually, in order to verify that everything went well, I check these 2 files at least. So this file, RoboPol source, should regularly look like this, but sometimes it looks like that. So the source selected as the main target by the pipeline is not in the squares, or nowadays it's circles. Then if I saw this, I would immediately open the RoboPol stacked, which is the stacked image of a series, and change the levels and see what is going on in the mask. And in this particular case, there is no single visible source in the mask. So I'm pretty sure that what happened here, the pointing was wrong. So the control system during the pointing did not find the source by some reason, or there was some wind gust or something like that. Something happened that the telescope is not pointed correctly, presumably. So maybe your target is somewhere in the field. So if you find that it's extremely important to measure it, you can try to visually identify the target. For this, you need to invert the y-axis in order to have north up, south down, east left, west right. For this, you need to flip the image around the horizontal axis. And then you can just visually identify all your sources and just to go to Aladdin or whatever, or DSS, and find this field that is supposed to be. And then you can perform, you can find your target center position, and then open RoboPol data CSV and find corresponding entry here, and use the corresponding parameters, right? But you should keep in mind that in the case of field measurements, uncertainties are actually much larger due to the dust specs that we already discussed yesterday. Okay. So in the data release paper, I wasn't using this kind of data. I was only using measurements in the mask. If I was meeting this kind of problems, I was just skipping this, trashing these files.
Sorry, can I ask another question? So you said the uncertainties will be higher because of, you said dust and things, did you?
Yes.
Are the uncertainties also higher though as well because they're outside the mask, so therefore you have mixing of sky and everything? Okay.
Exactly. The background is higher. The instrumental polarization outside of a mask is higher, and it's not necessarily perfectly accounted, especially in the edges of a field. Right. There could be some deviations from the instrumental model. And the third reason is these kind of dust specks that are sometimes your source can hit with one spot under the dust spec and 3 other spots are not, and then you get very strong artificial polarization. And this is well discussed in Gina's paper, because she was in this paper about Polaris flare, where she discusses all these issues and related problems. Yes.
So sorry, I know I missed yesterday's lesson. So are the images pre-processed before this step that you're describing today, like flat fielding and that sort of thing? Is that something that can be done on these files?
Yes, actually flat fields we did not discuss yesterday. So let's start with simpler things. So first of all, we were discussing that bias is extremely stable along these 8 years of observations. We take biases, but like once a month. And if you calculate median of a median, it's essentially this one particular number. So I just hard coded it in all my scripts basically, and I use the same bias. Okay. Then dark current is negligible, so we don't take darks. And the flat field, it is, I think, it is implemented nowadays in the pipeline, but there are several issues with a flat field, and we do take flat fields, morning and evening flats. So we have them if needed, but unfortunately we essentially cannot use them in the field, because every position here is actually has 4 rays from the sky, right? So potentially the skylight can be very different. I mean, the polarization state of a skylight can be very different at the moment when you observe this source compared to the polarization state of a skylight during the moment when we were taking flats, right?
So, okay, understand. Yeah.
so contribution, it is impossible to flat field in the field. It is only reasonable, in my opinion, only in the mask. Although I have seen some people were claiming that it's still better to do this, and I know people who have 2 rays polarimeters when instead of 4 rays on the CCD, you have 2 Savar plates, right? And each of them gives you two rays. And people still claim that it's better to flat field even in this kind of situation. At least you get rid of the largest specs like that, at least partially. I think we did not address this experimentally, whether it makes sense or not, but theoretically, it is not right to flat field in the field of RoboPol. Okay.
Okay, thanks.
Yeah, in the mask, again, we can do this. We can do the flat fields. We can consider these areas separately, like independently, and normalize flat fields, and then correct these areas for the interpixel variations, right? So again, kind of flat field them independently. But again, there is another serious trouble is that if you go, we have, as I was telling yesterday, 1 terabyte of FITS files basically. And if you just find the position of this center of this mask square of a square pattern, it will change with time and with position of a telescope in an unpredictable manner. So I could not understand. I was trying to plot the position of this mask shadow depending on the azimuth of the telescope, elevation on the moon phase, etc. And I could not conclude why it changes. And it changes significantly. It shifts more than the size of the square. So in the next night shot, you can have the square somewhere here, for example. Okay.
Wow. So is the mask not immediately above the CCD detector then? Is it further up the instrument?
Mask is located here. So this is the front lens. This is we are looking from the top. So this part goes to the telescope. It's attached to the telescope, right? And there the CCD is on the bottom of this image,
Okay.
on the other, on the opposite side. Right. And this is the mask. So the mask is located in front of the front lens.
Okay, so it's quite far from the detector surface.
Indeed,
then.
indeed. It's like, I think, order of 30 centimeters from the CCD.
Wow, okay.
I was discussing this problem of a mask movement with RAM, and unfortunately, we did not reach any final conclusion why this happens. Sorry, where was I? Yeah, we were talking about flats. So the thing is that we did not reach clear understanding what is going on. We even, at some point, we were even thinking that the CCD chip is not properly connected, not properly attached to the camera body. We know for sure that the mask itself is solidly glued to the body of the instrument. So we know that the mask is not moving. So maybe because the instrument is rather long, it's like 30 centimeters long, maybe if there are some flexures, so the mask is on the opposite side from the CCD. And maybe when you tilt the telescope to some high angle, high zenith distance, potentially it tilts, it's flexed a little bit, right? There is a flexure. But in this case, you would expect some correlation of a mask center position and the, let's say, elevation of a telescope, but I could not find such obvious dependence. So this kind of unsolved problem, and this makes flat fielding even in the mask problematic, because obviously if you take a flat and your mask is here, then you cannot use it to flat field this square during observations, right? So in the data release paper, we did not flat field.
Okay, I understand. Thanks.
Unfortunately, because it could increase accuracy, obviously. Okay. Let's move to problem number 2, which is cosmic rays. And here I show an example. Here you see the star or whatever blazer it is. And you see a bunch of cosmic rays, one here, and 2 here. So if you see this kind of situation that the cosmic ray is obviously next to your aperture, to the red circle, you should take care of it. And you should, when you call the constructor of a RoboPol pipeline instance, you should set this remove cosmic ray flag to true. It does increase the processing time. It runs some external library. I mean, it's some Python library that is based on some C code that was written many years ago. It's efficient, it works well, but unfortunately it's rather slow in Python, at least, because it's actually written in Python. So I typically don't run it every time with this flag true, because it increases processing time by a factor of 4 or something like that. So I believe that if you process the way I do it, like I explained before, if you plot this dependence of polarization parameters on the aperture, you should potentially trace the situation when you have a cosmic ray. So I usually run it without the cosmic ray cleaning procedure with this flag false. But if I see visually on the image that there are cosmic rays, or I see that this dependence does not converge, I try to run with a removal of cosmic rays. Okay. So this is straightforward. It works well. Yeah, I didn't see any serious issues aside from the processing time. Okay, I don't see what is the title of a slide. Problem number 3 is the different PSF of the 2 pairs of spots, as I explained you before. Depending on the temperature, on the focus position of a telescope, on the location of field in the sky, in the horizontal coordinates, I mean, we see that PSF and the ratio of PSF's characteristic widths, let's say, changes for the couple of spots. So typically these 2 horizontal spots are wider than the 2 vertical spots. And obviously, if you have the same aperture size for all of them, you will not have the optimal signal to noise, because as we discussed before, there are some optimal apertures that give you the best measurements, the best signal to noise. So for this reason, we made this option where you can say use 2 independent FWHMs for horizontal and vertical spots or not. So typically nowadays, I set it to true, this flag. So like in this case, it will set optimal aperture for horizontal spots separately and for the vertical spots separately. Okay. So it's just your choice whether you want to use it or not. It does not bother much the polarization parameters that are obtained by the pipeline. It's mostly it mostly influences the uncertainties of the parameters. Problem number 4 that you can meet is nearby bright source next to yours, source of interest in the mask. So this is one of the sources from Pablo's X-ray binary program. This is the source of interest, and there is a very similar brightness nearby star. And again, the best option how to avoid all sorts of problems related to this that I know, the only solution is to just to set the photometry method 3, which, as you remember, sets the fixed aperture size for all 4 apertures and set the desired aperture in arc seconds, let's say. So I would set for this particular source, I would set something like that, maybe slightly larger even, to have aperture basically in between the 2 sources. So again, I would do this in order to minimize the artificial dependence of a polarization parameters of this source on the seeing that you would also expect. Like if seeing goes really bad, then you will have more contribution from the other star, more light from the other star will fall in your aperture. And so potentially you can have some weird correlations of a polarization parameters that you obtain from this source depending on the FWHM, right?
Dima, I have a question. With these circles now, the circular mask, I mean, is the background estimation any different?
Yes, you spotted that. Let me see. You spotted probably that they are not so well aligned, right, with circles. Is this what you mean?
Exactly. Mm-hmm.
So first of all, yeah, in this particular case, I verified this background histogram. It's not the one. I'm just saying that I verified this background histogram, and it was looking pretty well. So in this particular case, there was no problem, even though you see visually that we're not perfectly aligned, right? Because the area in this circular mask is larger than in our previous square mask. You still have a lot of sky background that is pretty uniform in the mask. So even if you have these bad areas inside, you still easily find the mode of a distribution of background counts. Okay. Since you asked, the parameters regulating positions of these circles or squares, they are given in the config file by these parameters. So it's a bit more tricky. It's not simply fixed values. So now for the squared mask arrays, there are two there is a optimization procedure. So there are these parameters defining where these squares are located. But then after this preliminary guess that is set up in the config file, the pipeline runs an optimization procedure. So it finds, it slightly tunes the squares around, like scans all around, and it finds the location of the square where the counts inside the square are minimal. So we simply run optimization procedure in order to find the faintest position on the CCD. Okay. It does work. It is now implemented in the pipeline for the square mask. So the red squares actually show the initial position that is regulated by these parameters: mask box dx0, mask box dy3. So we define you x and y. X and y0 define this square. X and y1 define this square. 2 this square, and 3 is that one. So it's fixed. We use the same indexes for spots and for the squares. Okay. So these parameters, they define new positions of these red ones. And as you see in this particular case, the red one was not perfectly aligned with the actual shadow of the mask. This happens because, as I told you, the shadow of the mask moves on the CCD. So in this particular position of the telescope or temperature or focus position, the actual mask shadow moved slightly up and right. And then the pipeline ran the optimization procedure and found that it's better to place that particular square slightly right and up, and it was correct. The blue ones is what is actually used in the pipeline, and the red ones are the initial guess. Okay. And since I only recently implemented this circular mask thing, this algorithm is not yet implemented, so there is no optimization currently for the circles, but I will do it hopefully soon. So it will work the same way. It will tune them an automatic way to avoid this kind of misalignments when the circle is slightly away from the actual shadow. But currently what we have now is that these circles, background circles, they have fixed position and they're given by these parameters. So if I run it now, I see that they are slightly offset. I will just visually check and see, okay, my circle number 1, I want to move it left and up. So I will just go and change these two parameters. I will decrease x0 by 3-4 pixels and increase y0 by also 2-3 pixels. And then run again. And then I will see that this particular circle shifted left and up. Okay. So not very smart so far, but if you are interested, if you process just a couple of days of data, they're usually quite okay.
Dimitri, one question.
Yes.
Does that mean that we need different config files for the square, we observe with the square, the mask, and a different config file for the circle?
Okay, I think I understand. So these parameters, they are always in the same config, so they are kind of set there, and the default values that are there should be okay-ish, but the pipeline decides which mask it has, looking into the, let me see if I have all data. One sec.
So the pipeline is smart enough to know whether it is a square or a circle mask.
Exactly. So when we change the mask, we just change in the code, we change some value, and the control system, there is this header. The control system writes header of these feeds files. It puts the value true if it's circular mask now installed in the telescope, and it puts false if it's not, if it's the square old mask. Okay, and then the pipeline looks for this keyword in the header and automatically decides which method to use, squares or circles. Okay.
Okay.
So you don't need to bother. If you just see circles, you change these parameters. I mean, if you see that we are badly aligned, you change these parameters. If you have squares, they should align by themselves.
And to remember, a copy of the config file that you ran is stored in the output, right? So you can go back and see what you used for the different
Yes.
sources processed. Okay.
Exactly. So we discussed this yesterday, that in every output folder, there is this RoboPol _conf.cfg, and this is just a copy of a config file that was in use at the moment that when you run this pipeline. So you, for example, I processed some hundreds of measurements, and I just keep all this entire folder. And every time I have some questions, what was going on, I can just go back and see with which config file I was running the pipeline. Okay. So yeah, this is it about the positioning of the mask circles. So again, shortly saying, squares should be aligned by themselves, good enough. If not, you may try to tune these parameters slightly. And also there is this parameter max box width that defines you the size of a square. So there are some particular cases when you want to decrease it, when there are some issues, very bright sky, so the actual shadow is slightly smaller than it should be, because too much light comes from outside. So you can slightly decrease this width of each box. Or if you have circles, you can tune them totally manually. Also, you can change the radius here and the position. Okay. And this one we discussed. And problem number 5, extremely crowded field. This is one of the fields, again, from Pablo's project, because he observes stars in the galactic plane mostly. When you run a shot taken in this field, we have something like 20,000 stellar sources in the RoboPol frame. And the pipeline creates quite a lot of data. So for each of these stellar source, there are some, I'm not sure, kilobytes, but quite many bytes of data for each of the source. And if you have not enough memory, if you have only 4 gigabytes of RAM, you will have troubles. I think even with 8 gigabytes of RAM, you may have troubles. If you run the pipeline with default SNR cut, because it will try to measure all these stars, right? So it will take crazy amount of time and crazy amount of memory that even can stop the pipeline process if you have not enough memory. So the solution for this particular case is just to increase the SNR at the input. So if you remember from yesterday, at the very first stage, we run extractor in order to find positions of all the stars in the frame, right? And we can tell the pipeline that we want to use only stars, that we are interested only in stars with signal to noise or brightness, let's say, higher than particular value. So if I don't want to use all these little faint stars here, I just set these parameters extractor cut SNR to some high value, let's say 500 or 1,000 or several hundred, it depends. What is your exposure time, etc. So in this way, at the very first stage of pipeline run, we will just cut out very faint stars, and we will use much smaller amount of memory, and it will run faster. Okay. There are also other cuts. As you see, all these parameters are FOSS extractor. So you can, for example, you are not interested in very elliptical sources. You can put here ellipticity that you want to cut. If it's 0, it doesn't introduce any ellipticity cut. If you put something 0.5, it will cut out all sources with ellipticity higher than 0.5. Extractor cut edge is the distance in pixels, I think, to the edge of a frame. Extractor cut flag. Extractor produces binary flags that you can find, the meaning of which you can find in extractor manual. I don't remember exactly. I will tell you just as an example. It will, for every source, it sets some flag in the catalog of output of extractor. If it's, for example, 0, then the source is fine. It's a point-like, it has no problems. If it's 2, then it's, let's say, saturated. If it's 4, then there is some blending with nearby source, etc. So, and those values, they sum up. So you can have 2 plus 4, then you will have 6, right? And you can cut out all sources with extractor flag higher than particular value. So if you have 0, then you only accept sources that have all 4 spots of each in our frame are identified as good by extractor. So we have flag 0 in extractor's output, right? So the thing is that when this is the hardest cut, when you only analyze sources that have no blending or anything. If you want to allow, especially there is a problem with a mask. So for example, in this particular case, most likely this extractor will say that this spot here, it has problems because there is a huge gradient in the background. So the extractor will assign some value for the flag of this source. So in principle, you will cut out these kind of sources, but actually it's set in such a way that this flag does not apply to the central target. But all other sources located, for example, let me see. I hope you understand what I'm saying. It's a bit messy. So for example, for this star here, the extractor will assign some non-zero value of a flag. So if in the config file you set this value to 0, then the pipeline will not consider this star just because it's not ideal, something is wrong with it, as extractor thinks, okay? So if you still want the pipeline to use this star for some purposes for astrometry, because it will be cut immediately after extractor run. So it will not be used for astrometry, it will not be used for PSF estimates, it will not be used for anything. But if you have very few stars in the field and you still want to use this star, then you should set this extractor cut flag to some high values, depending on what kind of bad things you think are acceptable. If you set it, let's say, to 1,000, then any star-like object in the field will be used for further consideration in the pipeline, okay? I hope it's clear. If it's not, tell me.
Yeah.
Okay, now this problem, the target is too close to the mask edge, and this is the really a problem. As I told you, sometimes there are problems during pointing, either something went wrong or there was a gust of a wind, and before starting guiding, the telescope has been moved after pointing, and the source can be moved closer to the mask edge, too close, so that it becomes unmeasurable. So how to find out the situation? First of all, you can visually see that it's close. Second, in this kind of situation, you will obviously see some problems when you produce this kind of plots, dependence of polarization parameters on the aperture, because you will hit the edge of the mask. So plotting that polarization parameters as a function of aperture size, you will see that your aperture at some point hits the mask of edge of a mask, and it gets some photons, some light from outside of the mask, and you will obviously see some weird behavior in those growth curves. Okay, so that's why it's important to look for this convergence. And visually, in most of the cases, you can see visually that it's an unusable image. Just I have an example, this one. So I just opened this again, RoboPol stacked, the actual image that is used for the analysis, right? And I change the levels in such a way that I see the light outside of the mask. And then I just load the regions that we were discussing yesterday. This is the actual aperture size used in the processing, right? And I see that the light from outside of the mask actually enters the aperture. So unfortunately, in this case, we cannot do anything. And this goes to trash. So again, shortly saying, you should check the growth curve, how your polarization parameters change with a changing aperture. If you see it's not converging, and if you see that visually that your source is close to the edge, unfortunately, it's not usable. Okay, this is another common problem, misaligned aperture or aperture centered at the wrong source. So in this case, for example, there was a cosmic ray and it was apparently bright enough to confuse the pipeline in such a way that it selected that cosmic ray as the center of, as the centroid of this spot, right? And it gives you crazy, unrealistic polarization, obviously, because you measure something totally wrong in this aperture. The simplest way to fix it is to open config file and set these parameters, select manually to true. And then what happens in this case, if you do this change in the config file and run the pipeline like that, it will open you this DS9 window. Now you take these 4 circles and move them close enough. You align them, their centers with the images of a source you are interested, and then just click enter. So you, in this case, instead of running extractor to identify the centroids of the spots, the pipeline will run another procedure from the PyGuide library, and it will use as initial guess the positions that you set manually, centers of these green circles that you set in DS9. And usually it manages to find the proper centroid. So in this case, so this way you can solve this kind of problems when the extractor centroid is not correct, and you can also solve this kind of cases when you have two nearby sources and the pipeline automatically selects the wrong one, and you actually want to measure the other one. So you can do the same. You just set that select manually to true, and you align your circles with a proper source. Okay. Sometimes also, in some situations, just the changing of the size of the squares helps. So the problem here is that we have a huge gradient in the counts on the CCD at the edges of the mask. So sometimes the extractor gets confused. So it runs some kind of, it looks for the first momentum or something, for some statistical value, right? Just for each of the spots. And sometimes it finds a wrong position of a centroid just because of this large gradient at the edge of the mask. So sometimes slightly changing the square position or size of a square helps, and you immediately see that the circle jumps properly on the spot. Okay. Okay, we have last two problems. Problem number 9 is the bad background estimate. So as I told you, typically I just go to the output folder and I check these two images, the image with apertures and the image of the counts, the distribution of background counts. And I visually check that the red lines here, they reasonably well correspond to the, what I would say the typical background value is. If it's not, like it's shown here, it's artificially made, I just photoshopped it, I couldn't find an example. But anyways, sometimes you can see these kind of weird things that this automatic procedure that is looking for the peak of this background counts distribution, it fails and it gives you this estimate of the best guess background somewhere weird positions, or sometimes you have double peaks here. And if you are not happy with what you see, the way to change it is, first of all, you can try to change this background method. There are 1, 2, 3, 4 options. Typically I use mode, but you can try to use median or mean or centroid is some other way to find this. So you simply go to this config file, change it to another possible method and run again. And then again, check if the found background estimate is better visually in your opinion or not. And the second possibility is just to change the area, background area. As I told you, sometimes the actual shadow is smaller when we have very bright sky, for example, or something like that. You can try to tune to change the size of a square. As I told you, it's regulated by this parameter box width, mask box width. And sometimes it helps with this problem as well. So if you just slightly change this number, it may find it better. Okay, and now the last problem is not converging dependence of polarization parameters on the aperture size. So as I told you, the best way to verify that everything went well is to see these dependencies, as I was showing before for this photometry method too. The best method is to see visually that there is a plateau in both parameters, but sometimes you have this kind of dependencies, there is no plateau. And I would suggest to do the following 6 things that can potentially solve this problem. So first of all, you go and check the images, check the feed files, and check these 2 PNG plots that I was discussing multiple times already, that everything is fine there and none of the previous 9 problems is there. Okay, if you see one of those problems, obviously you need to solve it in the way I described before. Then you can go, you should check first of all the stacked image. If you have multiple fits images in your series that you combine, you check the stacked one. Again, just changing levels, see that everything is fine. There is an actual target inside. It's not too close to the edge. But then you can also go and check the raw images in your series. So you just open each of the fits files, input files, and verify that everything is fine there, because sometimes there are situations when like three shots are fine, and on the fourth shot you have like very elongated, instead of spots you have very elongated stripes. It means that it was a wind gust or something went wrong with guiding or something else happened. Okay, so then you just delete this one exposure and leave the remaining one that are good, and again run the pipeline again. Okay, so this is exactly why we split every long exposure in several multiple exposures, because in this kind of cases it saves you the measurement when only one of them is damaged. Okay, option number 3, you can try to use different methods to estimate these centroid positions that we were just discussing before. So even if you don't have this kind of situation, even if everything looks fine, like here, for example, you can still try to choose the background spots manually, as I was showing you just a few minutes ago, because still these are two independent methods, and they find slightly different centroid positions for each spot. And sometimes it helps to fix this problem. So sometimes you had this kind of curve dependence of polarization fraction on the aperture size, and you just run it different centroid estimator, the one from PyGuide, and it gives you perfectly stable dependence. Okay. Then possibility number 4, you can try to change the reference fits frame. So as I explained to you yesterday, we again have these multiple shots per measurement, and we have two possible libraries that align them into one reference frame, and those, they choose the reference frame by themselves in a random manner, I think. At least the preprocess chooses it by probably it chooses the best. It looks for the best WHM among these 5 frames, and the one with smallest PSF and with the largest number of sources in the field is chosen as the reference frame. Okay, and then it aligns all other 4 frames with the reference frame, and you see which one was the reference frame in the header of a final stacked image. On the bottom, there is this information. This is written by the preprocess, as you see. And the first one here is the reference frame. So it found 64 stars in that one. And it aligned all other frames to the same reference frame. And these are offsets, X and Y offsets in pixels. Here it was quite huge. Probably somebody was doing some shifts. Usually it's sub-pixels offsets if guiding is involved and nobody is moving the mask. In any case, sometimes this reference frame is not the best, although it's formally the best, but something is wrong with it. So you can try just to rename the file. Let's say to put, instead of 4, put 5 here, and then preprocess will choose another frame. Yeah, then I contradict myself. Apparently it's not using some smart algorithm. Yeah, I know for sure that if you just rename it, it will choose another reference frame. Okay, so just try to change the name and then run pipeline again and verify in the newly created RoboPol stack.fits that now it's another reference frame in the first here in this list is the first here, and then you may have a situation that your growth curve polarization parameters improved.
Sorry,
Actually,
say again, where do you change the name? Because you said that this is the stack file.
Yes.
But the stack file is the output.
The stack is output. So you just see which was the reference frame in the final output, right? And then you go back to your original data. They are listed here. I mean, you just put them somewhere, right, in some folder that you give in this parameter input dir. You put these feeds files inside of that input dir, right? And now you just physically go in this input dir, change the name, and change the name here. Okay. So usually it's enough to change this index in the series. You can put 5, for example, and the pipeline will find the number 1. I may think to do it smarter. I'm just too lazy. It's a little bit weird way, right, for now, but it works. It actually helps. So just to change the name of input files. Sometimes it solves the problem of non-converging dependence. Okay, option number 5 is actually, even if you don't see any cosmic rays, is try to switch on the cosmic ray removing mechanism. Sometimes it smoothens, slightly changes counts, or sometimes you can actually have a cosmic ray that you usually don't see, but it's there. Okay, so sometimes really you just go and switch on the cosmic ray removing, and it improves your convergence. Okay, and number 6 is the last one, is to, when none of this helps and you don't see any other problem, but your polarization parameters still do not converge, then you may try to process each of these frames separately. So you have these several independent frames. You just copy one to your data folder, to the input data folder, process it, keep the output folder, copy a second one, process it, again, keep the output folder. So do everything just with single images in the series. And then sometimes you can see that something is wrong with one of those frames, and all other have pretty much consistent Q&U output, and one of them kind of deviates. I don't know, sometimes visually nothing is wrong with it, but you just see it in the data that something was wrong. And then you can either just exclude that one, or you can, like here, you just directly find the final Q&U and polarization parameters, just summing or finding some function of these separate frames in the QU plane. So you can find, I don't know, sigma clipped median or mean or whatever you want. Okay. So this is all possible solutions that I managed to remember, and I think this is pretty much it for today. Do you have any questions?
Hi, Dima. Can you share then the presentation and the recordings? Apparently, there was some misunderstanding with the time. Sorry.
Yes, I will try to send them as soon as possible. Yanis recorded both presentations, so I will share them at the RoboPol webpage, non-publicly, but I will provide you the reference.
Great, thank you.
Any more questions?
Yeah, I had another small question. So in order to, for the pipeline, it used at least to be the case that we, there's a source list that you manually update with the name of your source. And there's also a, some file that has PTF or USNOB, I forget, lists of names. Maybe you said these things yesterday, but I don't remember. Are these still in implementation? And second, how do you download them if needed? So if you want to process a source that has never been processed before.
Okay, yeah.
And if you covered this yesterday, then I'll just look at the recording.
I only was talking about one of these things. So what Gina means is this file, if this environment variable is set properly, then it just points to the cloned, to the folder where you cloned the repository. And then there is a subfolder documents and file called RoboPol sources list. So this is the name. I don't know if you see, maybe this way is better. So this environment variable, documents, RoboPol sources list. It's a simple CSV file. Oops, not echo. It's a simple CSV file. It contains the name of a source, array, and deck. And the three last things are not important. You can put them 10.0.0 as I do here. So this is exclusively needed to give a preliminary guess of the position on the sky to the astrometry.net procedure. Okay. So if you don't care about astrometry at all, you can just put your source name and some random numbers here, right? It will just not identify the field, and that's it. If you want astrometry, you put the proper array and deck of your source and the name that you used in observations. It must be the same name that it was used during observations. Okay. This file now contains something like 4,000 lines, and if you want to process your data, you have to put your source inside. Otherwise, this function, the initialization method, gives you error or something like cannot initialize instance or something like that. Okay. Yeah, so this is unfortunately how it's done. Maybe I can change slightly the code and it will give you some at least notification, more human readable and understandable notification. What is it asking for? I will make a note somewhere. Okay, and the other thing Gina was mentioning is if I remember correctly, yes, in this RoboPol catalog there, it's pointing to some external drive that is not mounted to my laptop anyways. It's just again some folder that should contain CSV files, especially loaded. That I have a special script for this. Those CSV files that have photometric data from USNOB catalog for every field. And those are needed only for relative photometry. So if you are not only interested in polarimetry, but you also want to find magnitudes of your source, then you have to have them, right? And we did not discuss this topic. We totally avoided the possibility of, totally avoided discussion about the possibility of photometry. Yeah, and it's a long thing. And typically, this photometry is quite terrible because the USNOB catalog is a scan of ancient photographic plates from 50s, right? So, and the uncertainties there are sometimes 0.5 magnitude. So I don't find it's very useful. So this is all, photometry is relevant when you actually have your well-defined standards in your field. And so it's a special case, and probably we can discuss it some other time. Okay.
But will the pipeline run if there is no instance of the file?
Yeah, it must. In my case, as you see, it's not even mounted that drive that contains those files.
Okay.
So it must run. I believe it will. I mean, I was just running it and it was fine. Yeah. Well, if you don't have any more questions, I can say that potentially we can repeat this kind of hands-on session and to actually have it hands-on when you manage to install the pipeline and you actually play with some data, try to process, and then we can discuss maybe with several of you together, because probably you will meet the same problems. Probably we can make it more like question and answer section when you hit particular problem, and then I can listen and can try to solve it online. So we can repeat it as sometime later, this kind of training.
Yeah, that'd be great, Dimitri. Thanks very much.
It's a great idea.
In any case, we will keep these records of these videos somewhere in a place available for everyone, and these presentations and a few test files that you can use, and a couple of scripts. So we will be in touch, and if you need more assistance, more information, we can continue.
Sounds good. Thank you.
Okay, then if you don't have any more questions for now, then thank you everyone for joining.
Yeah. Thank you,
Thanks very
Dima.
much. Thanks.